Next, we also know for impact load, the work done upon the composite bar is equal to the strain energy stored in the composite bar. So this can be written as, we know the formula for work done for impact load is P into H plus delta L, where delta L is the elongation of this composite bar, and this is equal to total strain energy stored in the two composite bar. Now as we see that the two parts of this composite bar are in series, so delta L will be equal to delta L1, which is the elongation of part 1, plus delta L2, which is elongation of part 2. This will be equal to U1, which is the strain energy stored in part 1, plus U2, which is the strain energy stored in part 2. So the total strain energy stored in this composite bar will be algebraic sum of addition of the strain energy stored in the respective parts. So upon writing the formulas of delta L and U, we have delta L1 is sigma 1 L1 by E1, and delta L2 is sigma 2 L2 by E2, and U1 and U2 can be written as sigma 1 square A1 L1 by 2 E1 plus sigma 2 square A2 L2 by 2 E2. Now here in this equation we have two unknowns, sigma 1 and sigma 2. Upon substituting the value of sigma 2 in terms of sigma 1, we have P into H is 40 mm plus sigma 1 into L1 is 1000 mm upon, since the two parts are of same material, we have value of E1 and E2 equal to E, which is 200 into 10 to the power 3. So E1 is 200 into 10 to the power 3 plus sigma 2 we know is 1.77 times of sigma 1, as we have derived it in the previous slide. This multiplied by length L2 is 1000 upon E2 is same 200 into 10 to the power 3. Now this is equal to sigma 1 square into A1 L1 is 314.16 into 1000 upon 2E plus sigma 2 square. Sigma 2 is 1.77 times of sigma 1. So this is square multiplied by A2 176.71 multiplied by 1000, the whole upon 2E. So upon substituting the value of P, which is 981 Newton, we have only one unknown here as sigma 1. So upon simplifying this equation, we get 39240 plus 13.59 sigma 1 is equal to 2.17 sigma 1 square. So upon rearranging, we get sigma 1 square minus 6.26 sigma minus 18082.9 equal to 0. This we get by dividing the whole by 2.17 and rearranging it. So we see that this is a form of a quadratic equation. So upon solving, we get the value of sigma 1 as 137.63 Newton per mm square. Now using the relation in equation 1, we get the value of sigma 2 is equal to 1.77 of sigma 1. So we have 1.77 multiplied by 137.63, and this is equal to 243.62 Newton per mm square. Now the maximum of the two value is 243.62, which is the stress produced in part 2. So this is our maximum stress and our answer 1. Next we find out the elongation. Now we know elongation delta L of the composite bar will be given as delta L of 1 plus delta L of 2. Upon writing the formula for delta L's, we have sigma 1 L1 by E1 plus sigma 2 L2 by A2. So upon substituting the values, we have 137.63 into 1000 upon 200 into 10 to the power 3 plus 243.62 into 1000 upon 200 into 10 to the power 3. So upon solving this, we get the value of delta L is equal to 1.90 mm. So this is your answer 2. So with this, a problem is solved. Thanks for watching in 5 minutes.